So in this vector application problem, we have two forces that are acting at an angle towards each other, and we want to find the magnitude of the resultant force. So the easiest way to do this is to say, all right, this is the point of insertion where these two things are connected to this body. So we're going to make one of them point directly to the right, and this will be the 30-pound force just because it comes first. And then we'll make this other one the 27.8-pound force, and it has to act at 60 degrees. So we'll come up from there 60 degrees, and there we go, 27.8. Okay, now in order for your brain and your eyeballs to match up, you should draw these things so that they're basically the same. So 30 is this length, and 27 is a little bit shorter than that. So that looks pretty good as far as visuals go, just so that your eyeballs believe your math. Okay, so what we're going to do is we're going to make our parallelogram. So we come over here and put our 27.8-pound force over here, and you put your 30-pound force up here. And where these two things form a parallelogram is where your resultant or your answer. So this is going to be the force that is the result of these two things acting at that angle. So this is what we're looking for. Basically the length of this line. So we'll call this x. Now, in order to do this, let me write down this. So this is 27.8 over here also because it's a parallelogram. It would be really nice if I knew the measure of this angle right here, because then I would have side, angle, side, and I could use the law of cosines in order to solve for that length. That would be cosines to solve for my resultant there, which is good because in a parallelogram, these two angles add up to 180. So if that much is 60, that means this one has to be 120. Okay, so because it's a parallelogram, this angle here and this one, these consecutive angles, are supplementary. So if this was my 60-degree angle, then this one would be 120 degrees, because this and this from our parallelogram are supplementary. Okay, so I can know that angle, and now that I do know that angle, I can use the law of cosines. So x squared equals 30 squared plus 27.8 squared minus 2 times 30 times 27.8 times the cosine of 120. So I put all this into my calculator. I take the square root of it, and bear with me, times the cosine of 120, and I get a resultant magnitude force of 50.068 pounds. So if I had a 30-pound force and a 27.8-pound force acting at 60 degrees to each other, that would give me a resulting force of a little more than 50 pounds acting right there in that direction.